So guys, we are starting with question number one, sub question one from 2C. Okay. Now they have given f of x is equal to 2x plus 3. We need to find out f inverse of x. So we don't have to prove that it is invertible. They are not asking us to prove. Okay. Just have to find out f of x, f inverse of x. So y is equal to 2x plus 3. Y in terms of x will go to x in terms of y. So y minus 3 upon 2 is equal to x. Okay. So x is equal to y minus 3 upon 2. Okay. So f inverse of x equal to x minus 3 upon 2. That is the final answer. Okay. So question number, sub question 2 and 3, you can solve it for self-study. If it is y in terms of x, you get x in terms of y and you can solve it further. Question number 2. Question number 2. F of x is equal to 2x plus 1 upon 1 minus 3x. So y is equal to 2x plus 1 upon 1 minus 3x. Okay, y in terms of x, let us get x in terms of y. Y 1 minus 3x is equal to 2x plus 1. Y minus 3xy is equal to 2x plus 1. Okay, now we have to write x in terms of y. So group all x terms together. And non-x terms you separate it. 3xy minus 2x minus 3xy. I'm sorry. This will be 2x minus 3xy. Take x common, 2 minus 3y. So x is equal to y minus 1 upon 2 minus 3y. So f inverse of x, replace y with x, will get your answer. That is question number 2. Let us go to question number 3. Okay. F of x is equal to 1 minus x raised to 1 by 3. So y is equal to 1 minus x raised to 1 by 3. 1 by 3 power, if it is going on the other side, it will become 3. Okay. Therefore, x is equal to 1 minus y cube. Okay. So f inverse of x is equal to 1 minus x cube. X in terms of y, then replace y with x. Okay, that was question number 3. Let us go to question number 4. F of x is equal to 4 minus x minus 7, the whole raised to 1 by 5. So y is equal to 4 minus x minus 7, the whole cube raised to 1 by 5. 1 by 5 as a power, if it is going on the other side, it will become 5. 4 minus 7 minus x raised to 3. Okay, therefore x minus 7 raised to 3 is equal to 4 minus y raised to 5. Now send this 3 on the other side. If this 3 is going on the other side, it will become 1 by 3. So x minus 7 is equal to y minus y raised to 5 minus 4. Just a second. 4 minus y raised to 5. 4 minus y raised to 5 raised to 1 by 3. Okay. So x is equal to 4 minus y raised to 5 raised to 1 by 3 plus 7. So we got x in terms of 1. So f inverse of x is equal to 4 minus x raised to 5 raised to 1 raised to 1 by 3 plus 7. Okay. Next problem. Question number 5. See, they have given function is defined from natural numbers to y. And what is y? Y belongs to natural numbers such that y is equal to 4x plus 3 for some natural numbers. Then find the inverse of f. Okay. So basically that really doesn't matter. We'll just calculate the inverse of f. So in question number 5, the initial amount of information hardly matters for this problem. They're not asking us to calculate the values of y. Okay, so y is equal to 4x plus 3, y minus 3 is equal to 4x, x is equal to y minus 3 upon 4, f inverse of x is equal to x minus 3 upon 4. Okay, so this is your answer. That initial part of the uh, question does not really matter at all. Okay, yeah. Question number 6, f of x is equal to x cube, y is equal to x cube. So y raised to 1 by 3. 3 as a power, if it is going on the other side, it will become 1 by 3. So x is equal to y raised to 1 by 3. So f inverse of x, we got x in terms of y. Replace y with x raised to 1 by 3. But then they are asking f inverse of 8. So 8 raised to 1 by 3, that is cube root of 8, which is 2. Okay, yeah. So let us go to question number 7. It's a conceptual one. F of x is equal to modulus of x. Now see, uh, this mapping is real number to real number. Okay, so modulus of 0 will be 0. Modulus of minus 1 will be 1. Modulus of 1 is also 1. Modulus of minus 2 is 2. Modulus of 2 is also 2. So this particular function is not 1 to 1. It's many to 1 because two objects are pointing towards the single object. Okay, except for 0. Okay, so it is not 1 to 1. So if it is not 1 to 1, it is many to 1. Then it is not bijective and hence inverse does not exist. Okay, question number 8. Yeah, so they are asking us to prove whether the function is invertible or not and also to find out um, the inverse. Now f of x is equal to 4x plus 3. Step 1, to prove 1 to 1. So f of x1 is equal to 4x1 plus 3. F of x2 is equal to 4x2 plus 3. Okay. Now f of x1 is equal to f of x2. Therefore, 4x1 plus 3 is equal to 4x2 plus 3. 3, 3 gone, 4, 4 gone. x1 equal to x2. So this is 1 to 1. Okay. We have to prove it is bijective, then only it will be invertible. Step 2, y is equal to 4x plus 3. So y minus 3 is equal to 4x. Therefore, x is equal to y minus 3 upon 4. Okay. Now mapping. After this, we have to draw the diagram and analyze few things. Okay. A has x and B has f of x and f of x is nothing but y. Okay. And the mapping is for real numbers to real numbers. Now you take any real value of y, any real value of y, 0, 1, 2, 3, 4, or minus 1, minus 2, minus 3, or positive decimal, negative decimal. Okay. And put it over here. Will we get a real value of x? Yes. So if you're putting y as 0, 0 minus 3 by 4 is minus 3 by 4. Minus 3 by 4 is the value of x. So x is real. Okay. If you're putting y as 100, 100 minus 3 by 4, 97 by 4. It's a real number. Okay. If you're putting it as minus 100, minus 100 minus 3 upon 4 is minus 103 upon 4. Negative but still real. We are getting the value of x as minus 101,103 upon 4, which is negative, real. Okay, so for every real value of x, okay, for every real value of y, sorry, there will be a real value of x. Okay, so for all objects in the codomain, I'm dictating this. For all objects in the codomain, there will be a pre-image in the domain. Okay, therefore on to. But then these statements you need to write up. Okay, therefore it is on to. Now it is one to one, it is on to, hence it is bijective. Should write this. The function is one to one as well as on to, therefore it is bijective, therefore inverse exists. The function is invertible. Okay. Now how to calculate further? All those statements you write. Okay. F inverse of x will be x in terms of y, replace y with x. This is the final answer of step 2. Okay. That was your question number 8. Let us proceed with question number 9. Okay. So f of x is equal to x upon x plus 2. Step 1, f of x1, okay, equal to x1 upon x1 plus 2, f of x2, x2 upon x2 plus 2. F of x1 is equal to f of x2, x1 upon x1 plus 2, x2 upon x2 plus 2. Okay, cross multiply. So x1 x2 plus 2 x1 is equal to x1 x2 plus 2 x2. So x1 x2 x1 x2 1, 2x1 is equal to 2x2, therefore x1 equal to x2, therefore 1 to 1. Okay, now let us go to the second step. Step 2, y is equal to x upon x plus 2. So y into x plus 2 is equal to x. xy plus 2y is equal to x. X terms, we have to keep it together. So xy minus x is equal to minus 2y. X, y minus 1 upon minus 2y. So x is equal to minus 2 y upon y minus 1. Now from the denominator, I'll take minus sign common and I'll reverse it. Okay, so x is equal to minus 2y minus of 1 minus 1. Okay, y minus 1 will become 1 minus y. So x is equal to 2y upon 1 minus y. Right? Now analysis. A has x, B has f of x. Correct? A has x and B has f of x. Okay. Now x values are only between minus 1 and 1. See, the mapping is given. It is only between minus 1 and 1, including those numbers. And y values are all real values. Okay. So this is the mapping. So for, I just wrote wrongly over here. It should be y. Sorry. F of x. Okay. So for any real value of y, you can put any real value of y. The answer will be between minus 1 and 1. Let's take y as 0. So 2 into 0, 1 minus 0. So this will be 0, right? So it is lying over here. Put any real value of y. Okay. Let's put y as 1. Okay. Just a second. y as 1 over here. So for 1, I think if we put y as 1, so there is no pre-image. So this will be not defined. Not defined is not a part of this. Okay. I think in the mapping, they should have written, there is some conceptual error in this, I think. It should be real number except 1. So they have not mentioned this except 1. So we have to consider that it is except 1. Okay. Ideally, it should be except 1 because 1 in the denominator will make the entire function not defined. So y cannot take up the value of 1. Okay. They have not mentioned this, but then yes, so I'm telling you from my end that real the value of y, that is f of x, is real numbers except 1. Okay. Yeah. Then take y as 2, for example, 1 minus 2. So this will be 4 upon minus 1. Okay. So that is minus 3, right? Okay. So I guess over here, the function is 1 to 1, but then it is not on to. So invertible, we have a doubt. Like, I don't know, like how they have framed this particular problem. It's a bit incorrect because it's not 1 on to. So I think the problem becomes very vague over here. Okay. They should have not framed in such a way. Still, they're asking you to find out inverse. So if at all such problem comes, then just write down x in terms of y, and then you can write this. But then the problem does not make any sense because that it's not on to, right? Okay. Let's go to question number 10. Okay. F of x is equal to x minus 1, x minus 2. We have to prove it is 1 to 1 and on to, and then f inverse. Step number 1, f of x1, 2x1 minus 1 upon x1 minus 2, f of x2, x2 minus 1 upon x2 minus 2. F of x1 is equal to f of x2. We have to equate. It should give you x1 equal to x2. If it is not giving you x1 equal to x2, then the function is not invertible. So 2x1 minus 1 into x2 minus 2 is equal to x2 minus 1 into uh, x2 minus 1 into x1 minus 2. Okay, why am I writing that 2? 1 second. There is no 2 over here, sorry. Okay, so multiplication of these brackets will be x1 x2 minus 3x, 1 second, x1 x2 minus 2x1 minus x2 plus 2 is equal to x1 x2 minus 2x2 minus x1 plus 2. Okay, so cancellation of some terms on both the sides. Okay, so you can take x1 terms together. Minus 2x1, you put it on the right hand side, and minus 2x2, you put it on the left hand side. Okay, so minus 2x2 on the left hand side and 2x1 on the right hand side. Okay, so x2 is equal to x1. Therefore, it is 1 to 1. Okay, fine. Now, step number 2, we have to prove it is onto. So y is equal to x minus 1 upon x minus 2. So y into x minus 2 is equal to x minus 1. Xy minus 2y is equal to x minus 1. Prove the x terms, club it, take x common. x is equal to 2y minus 1 upon y minus 1. Okay. Now analysis, A has x and B has f of x. F of x is nothing but y. The the mapping over here is from A will be real numbers except 2. 2 is not allowed. And here is real numbers except 1. 1 is not allowed for the value of y. So this is the mapping. So y can take up any real value apart from 1. Because 1 minus 1 will give you 0. That's what I was speaking in the previous problem also. But then previous problem was totally vague. Okay. Yeah. So we can put any real value of y except 1. If you put y as 0, so it will be 2 into 0, that is 0, minus 1 upon 0 minus 1. So that will be minus 1 upon minus 1, which is 1. Now 1 is a real number. Okay. Now this x value cannot be 2, and we'll never get 2, don't worry. Put any other value of y, any real value. You will definitely get some answer for x, which is a real number. Okay. So for every real value except 1, every real value except 1 of y, there is a real value except 2 for x. So for every object in the codomain will not have 1. Okay. Codomain will have all real numbers except 1. For every object in the codomain, there will be a pre-image in the domain. Therefore, it is onto function. Now, since it is 1 to 1 and onto it is bijective, you should write that. Therefore, it is invertible. So f inverse of x is equal to 2x minus 1 upon x minus 1. Okay. Yeah. So question number 12 and 14 also you can try it on your own. Okay. Question number 12 and 14 you can try it on your own. It's similar, right? In question number 14, you need to prove that the f inverse of x is f of x. It is the function itself. Okay. Yeah. 12 and question number 11 and 14. Sorry, not 12, but then 11 and 14. You can try it on your own. 13 and 15 is not there in your syllabus because it is composite functions. Let us go to question number 12 right now. Again, question number 14. The hint is find out f inverse of x. You'll get some value and check whether f inverse of x is equal to f of x. We're asking you to prove that the inverse of the function is the function itself. Okay. Yeah. Let us go to question number 12. Okay. So f of x is equal to x square plus 4. X square plus 4. F of x1. So step number 1 is equal to x1 square plus 4. F of x2. X2 square plus 4. F of x1 is equal to f of x2. Therefore, x1 square plus 4 is equal to x2 square plus 4. 4 will get cancelled. Okay. So x1 square is equal to x2 square. Now the discussion is very important over here because this is square. So square will give you plus minus in the right hand side. It can be, we can write plus minus x2 on the right hand side. Okay. But then for this problem, we'll consider only the positive values because the mapping, this x1 and x2. Okay. See, look at the mapping r plus and 4 to infinity they have given. Okay. So this x1 and x2 values, these are x and x belongs to the first set and this is y. So these are positive real numbers only. So there is no question of taking minus sign. Okay. So hence x1 equal to x2. We have done this kind of problems in the first exercise as well. Yeah. So x1 equal to x2. Therefore it is 1 to 1. Right? Let us go to Second one, that is to prove it is onto. Step 2, y is equal to x square plus 4. Y minus 4 is equal to x square. Therefore, x is equal to root of y minus 4. Okay. Now see, if this y value is less than 4, y value greater than equal to 4 is okay. But then if it is less than 4, we'll get all negative numbers within the root. Okay. So that's the reason why they have mentioned y values are more than or equal to 4. Okay. More than or equal to 4. 4 comma infinity they have mentioned. So this is a which has x, b has f of x is y. And these are positive reals over here. Okay. So see, y value, you cannot take any random value. You have to take only real value which are greater than or equal to 4. So y is greater than or equal to 4. So you put any y value greater than or equal to 4. The square root of it will give you a real number only. Okay. A real number only. Okay. And we have to consider only positive reals because they are defining the values of x as positive reals. So we'll get positive reals also, na? Right? Okay. So I think this function is onto as well. For every value of y which is greater than or equal to 4, there will be a value of x which is positive real. Okay. So that's the reason why it's a onto function. And since it is onto function, okay, now some people might be confused. For example, if you are taking the value of y as, let's say, 20, 20 minus 4 is equal to 16. So the answer is plus or minus 4. But then try and understand, we cannot take minus 4 because this x set has only positive reals. So there is no minus 4 present in this particular set. So we have to take only positive 4. Okay. Right. So that's the reason why for every real value of y which is greater than or equal to 4, there will be a positive real value of x in the domain. So for every object in the codomain, there will be a pre-image in the domain. Hence, hence, okay, uh, it's an onto function. Now, some more clarification I would like to give. This A set, they have said positive reals, but then they should write zero union positive reals. Okay, zero union positive reals. Because see, if you take the value of y as 4, we can take the value of y as 4. There's a box bracket over here. Okay, right? So when y is 4, x value is 0. So 0 also can be included in this set. So they should have mentioned that the mapping is not only r plus, it is 0 along with r plus. Okay, so it's invertible. So this kind of vagueness is there at times while framing the questions. Okay, so it's an onto function, and then since it is one to one and onto, it's bijective function. Now look at this. From this, we'll get the value of f inverse. See, if it is bijective, it is invertible. So inverse is root of x minus 4. Yeah. So that's it. That was question number 12. Thank you.